A tank contains 20 kilogram of salt dissolved on 5,000 liter of water. So this water contains 5,000 liter of water. However, we have to be very careful here on this 20 kilogram, not to write it here, but let's write that as X kilogram. Why? Because the amount of X changes over time. And this 20 kilogram is the initial condition. So I will have X0 is equal to 20 kilogram, right? That is the initial condition. Brine that contains 0.03 kilogram salt per liter. So we will have salt here, and that will be 0.03 kilogram per liter, and that will flows in at a rate of 25 liter per minute. 25 liter per minute. Okay, and that is the rate of the brine. But we need to find out the rate of the salt, right? So the rate of the salt, we can just multiply these things. So I'll have 0.03 multiplied by 25. And the unit will cancel out, right? Liter and liter will cancel. So we will have 0.03 multiplied by 25. That will be 0.75 kilogram per minute. That will be salt that goes in. The rate of the salt goes in. And then let's see here when the salt is going out. It is going out with the same rate, which is 25 liter per minute. Okay. However, we don't know the concentration of the salt here, but we have it as a variable, which is x over 1000, right? No, x over 5000, x over 5000, and that will be kilogram per liter. And if we multiply this, we will have, okay, what is this? So we'll have x over 200, right? X over 200 kilogram per minute. And that is the rate of the salt that is going out. So that is rate of the salt that going out. And how about the rate of the salt that inside the tank? So that will be our dx dt. And that will be our rate in minus rate out, right? But then what is the rate in? We will have this one here, 0.75. Okay, let's plug that in. So we'll have dx dt is equal to 0.75. And then the rate out is this one here, x over 200 kilogram per minute. So we will have minus x over 200. Good. Maybe let's multiply both sides by 200 to simplify these things. So we will have 200 dx dt, and that will equal to 150 minus x. Okay, we can isolate x to the left hand side. So we'll have dx divided by 150 minus x, and then we will have dt over 200. Good. Now we can integrate both sides here, right? So we'll have integral of this thing and integral of these things. And this one I will have ln of 150 minus x. But because of the chain rule, we have minus 1 here. So I have minus ln that one. Okay. And then we will have this one, and that one will be t over 200. T over 200, and then plus some constant. Okay. And then we can just move this negative sign to the right hand side, right? So we'll have minus there. Okay, and the c becomes minus c. However, because that is arbitrary constant, minus c also a constant, so I don't need to rewrite that, right? Okay, so we can take the exponential of these two things. So I have 150 minus x is equal to e to the minus t over 200 plus c. But then we can rewrite this as e to the c, right? So I'll have e to the c, but e to the c is just a constant. So I'll have 150 minus x is equal to some constant multiplied by e to the minus t over 200. Now isolate that for x. So I will have x that will equal to 150 minus a e to the minus t over 200. And remember that x is dependent on time, so we will have xt here. Good. And all that we need to do is to find out a, how we can use the initial condition x0 is equal to 20. Okay, let's clean this up and find that out. Okay, now let's plug in the initial condition. We know that x0 is equal to 20. But here, x0, that means that we will have 150 minus a e to the minus 0 over 200. And that will equal to 20, right? But then remember, e to the 0. So e to the 0 here is equal to 1. So a multiplied by 1 is just a. So I have minus a here. And that will equal to 20. Therefore, we will have a is equal to 130. Good. And so we can just plug a into this original equation. We will have x of t that will equal to 150 minus 130 e to the minus t over 200. Good. And then, what is the question? How much salt will there be after half an hour? Okay, half an hour. So we need to find out when t is equal to 0.5 hour. However, the unit here is in minutes, so we will have t is equal to 30 minutes, right? So we will have x of 30 here. And that will be 150 minus 130 e to the minus 30 over 200. And I think nothing that we can do except plug this into calculator, right? That is hard to calculate. Okay, and that is our calculator. And we will have 150 minus 130. And then we will have e, and then we will have minus 30 over 200. And we will have 38.1. Okay, so I have 38.1. And the unit here will be in kilogram. And this is an approximate value. Okay, and that is all for this problem, I think. Thank you for watching. And see you in the next video. Bye bye.